We've all dealt with a shopping cart that has a stuck wheel, making it hard to push. So everyone will laud a wheel-free air cart. This invention is a quadcopter enclosed in a cage for safety with a loading platform on top. The cart hovers at chest height, allowing the person to push it in any direction by hand. This makes it easy to move items over smooth floors and even go over thresholds and steps without trouble. The platform can carry up to 6.5 pounds and stays level no matter the floor surface. Have you ever seen a quadcopter with a leg? A team of researchers from the City University of Hong Kong added a spring-loaded telescopic leg to a classic drone, which greatly expands its abilities. Thanks to this, the hybrid can switch between flying and jumping up to 5 feet high depending on the terrain. The developers took inspiration from sparrows and small parrots, which hop short distances on the ground. This allows the drone to move under low branches where flying is impossible. The spring-loaded leg protects the drone from ground impacts during low flights, and jumping helps extend its battery life. The invention is planned to be used for search missions in difficult environments. But 3D printers can print with more than just clay or soil. Scientists from the University of Massachusetts have created a machine that prints bricks made of glass. These bricks can then be used for building structures and facades like Lego blocks. They connect using a locking mechanism at the base. The machine extrudes liquid glass in the shape of an 8, and once it hardens, the brick becomes transparent and strong. To test the brick's strength, it was placed under a powerful press to see when it would crack or break. Each glass brick can withstand pressures similar to that of a concrete block. Additionally, these bricks can be melted down and reshaped into new forms since glass melts easily. You can already see such a wall in person. It's built right across from the university building. Meanwhile, scientists from Singapore came up with their own version of a drone by creating a monocopter. It has just one propeller located at the edge. The drone folds up, reducing its size by 69%, and easily fits in the palm of your hand. Most of the body is made of lightweight wood coated with plastic. The battery is positioned on the opposite end. The monocopter flies by spinning the propeller, which rotates the wing in a full circle. The lightweight body lifts due to aerodynamic forces. If the power fails, it gently lands without damage. Although the camera image may be blurry, the plan is to equip it with GPS and other sensors to monitor the climate. This will help detect weather changes early and warn about forest fires. Here's how food will be delivered by drones in the near future. Companies Serve Robotics and Wing are developing a robotized system to deliver burgers and fries within a 6-mile radius from restaurants to customers. Here's how it works. An employee places the order into a robotic loader, which autonomously moves outside and sets the package in an auto loading station. The drone then flies in, lowers a cable, hooks the package, pulls it up, and flies off on its said route. The whole process is managed by AI. The project will start in Los Angeles with Shake Shack restaurants delivering orders within 30 minutes, avoiding traffic jams. Every day, 22 million corks are made for wine bottles worldwide. A single factory can process up to 5,000 tons of cork bark each month. But where does all this material come from? It's the bark of the cork oak tree, harvested during rapid growth in spring and summer. After being cut, the bark regrows over 9 years, allowing the process to repeat. Cork suitable for wine bottles starts growing only about 40 years after a tree is planted, and the tree can continue producing for the next 150 to 200 years. Harvesting cork is a labor-intensive manual job and one of the highest-paid agricultural roles in Europe. First, a sensor measures the moisture of the bark to determine if it's ready. Then, electric saws cut the bark into segments, with rollers controlling the saw's depth to avoid damaging the tree. A tool separates the bark edges, and workers use special axes with short curved handles to carefully peel away the bark in sheets. Precision is crucial as mistakes can harm the tree. Each tree is marked with a number indicating the last year it was harvested. For example, a 4 would mean it was last harvested in 2024. The harvest period is short and completely manual. If missed, they have to wait another year. Skilled cork harvesters are rare, and no mechanized method has been developed. Cork oaks grow in Spain, Portugal, and California. For example, the University of California, Davis has 532 cork trees. In Portugal, cork forests have been legally protected for over 800 years, with strict laws against cutting down these trees. If we ask 10 random people who the fastest person on the planet is, everyone will undoubtedly say Usain Bolt. It's clear and obvious. But I had a different question in mind. What is the fastest robot? Meet the first contender called Achires. This is a bipedal robot that runs like a human with its body leaning forward. This approach helps it maintain impressive stability. The humanoid can overcome obstacles up to 10% of its leg height and doesn't fall, even if it's poked with a stick. It runs in a funny way, but still not nearly as fast as an Olympic champion. Now meet the current fastest robot, the bipedal robot KAIST Raptor, which runs like a dinosaur. The machine's top speed is 28.5 miles per hour. This success was achieved thanks to its lightweight carbon fiber construction and 2 motors, one for each leg. The developers included a mechanical Achilles tendon that acts as a shock absorber, helping it stay stable on landing and push off better. Additionally, a counterweight disguised as a tail helps it balance at high speeds. To make a robot's arm move, at least 3 actuators are needed. The setup is bulky and the movements are still not as precise as a human arm. But this is changing thanks to a new invention by Japanese scientists. They developed an innovative joint based on a spherical gear that can rotate 360 degrees in any direction. It's controlled by 2 side roller gears that move back and forth along the longitudinal axis. The attached arm can perform movements with amazing accuracy. The potential uses for this invention are limitless. It could be integrated into a surgical robot for precise, minimally invasive operations, or into a dental robot for careful teeth cleaning. Rover arms could use it to build habitats on Mars, and spacecraft arms could become multifunctional, enabling them to repair space stations. We've already told you about this hybrid car with an additional flying module stored in the trunk. So far, it's only been shown in computer models, some of which didn't even look very realistic. However, a physical prototype was recently displayed in Guangzhou, and the first flight tests were successful. In reality, it looks just like it did in the computer simulations. The car measures 18 by 6.5 feet, fitting easily in a parking space. During testing, the flying module took off vertically, made a circle, and landed accurately at a designated point. Owning such a hybrid vehicle would allow you to travel deep into the mountains to relax in a scenic spot, while the flying module lets you view everything from above, fully enjoying the beautiful scenery. Now, let me show you the most innovative vertical farm in the world, located right in an urban block in Compton, California. This farm can grow up to 4.5 million pounds of leafy greens a year. It's housed inside a building, allowing it to operate year-round and independently of weather conditions. Unlike other indoor farms, it uses vertical towers as tall as a 2-story house instead of horizontal fields. First, seedlings in square soil pots are placed in long horizontal trays. Then, a robotic arm sets them in a vertical position, enabling multiple rows to be stacked compactly and saving space. Inside, the farm has a watering system and lighting designed for photosynthesis. When the greens are ready, the robotic arm removes the vertical rack and places it in a machine that trims the leaves with a sharp blade. The greens are then transported by conveyor belt to a packing station where they're sorted into trays for delivery to stores and restaurants. To optimize growth, the farm uses data from over 2 million inputs collected over 2 years of development. It grows arugula, lettuce, and spinach, achieving yields 350 times higher than traditional methods on 1 acre of land. This new technology makes healthy food production more affordable and closer to cities. Here's another construction technology developed in Switzerland. Its main feature is high-speed building without the use of cement, relying instead on 3D printing. The base materials used are clay, silt, or soil. A robot shoots out each portion at a speed of 33 feet per second. Due to the strong impact, each new layer sticks to the previous one without needing much adhesive. Unlike concrete, there's no need to pause for curing. The machine quickly creates columns, walls, and even window openings. It can build 1- or 2-story structures. If needed, the protruding parts of the walls can be smoothed down to create a flat surface. This invention speeds up the construction of various buildings using local soil materials, saving costs significantly by eliminating the need for cement. Scientists have used the natural color-changing abilities of Squid-skin to create a way to encrypt images without electronics. They designed a flexible screen that can store visual symbols made from tiny magnetic particles. The screen is controlled by a magnetic field with programmable keys. Through these fields, specific symbols like letters or numbers can be displayed. Without the magnetic influence, the particles mix freely, appearing as simple grains. But when placed in a special field, they align into the original image. This device can show dynamic messages like a scrolling text and only responds to a specific magnetic field, ignoring all others. This makes it possible to encode a barcode, sticker, or symbol on clothing that can be read only with a special device, without any electronics needed. The next contender set a world record, beating Usain Bolt. A 4-legged robot developed by the Pentagon reached a speed of 28.3 miles per hour on a treadmill, while the Olympic record is 27.78 miles per hour. The robot doesn't have a head, and its pared-down limbs move in sync. It moves in leaps, imitating a cheetah, the fastest animal on Earth. Its movements, as well as the bending and extending of its back, are modeled after those of a cheetah. Although it operates using hydraulics and is intended for military use, it could be useful in hunting, herding sheep, or agriculture in the civilian world. If a regular quadcopter hits an obstacle, it gets damaged and can continue flying. The same happens if it falls to the ground due to a lost connection or a drained battery. But now, this problem is solved with a new drone that has 3 propellers placed inside dots, preventing them from hitting anything around. To control the drone's movement, curved nozzles at the ends of the ducted fans adjust, directing the airflow as needed. The drone can hover in place, rotate around its axis, and hold a tilted position. This invention, created by engineering students from a technical school in Zurich, Switzerland, is ideal for inspecting industrial sites. These inspections often require flying in tight spaces that are hard for humans to reach. With this new drone, such flights are now much safer. The gap between the abilities of robots and humans is getting smaller. Recently, a mechanical hand with 5 fingers was invented, working similarly to a human hand. Each finger has 3 sections or phalanges that bend using cables similar to strings. They straighten with the help of reverse cables and springs. Behind each cable, there's a spool and an electric motor. This mechanical hand can make gestures, form a fist, and grip objects like a soda can, a tennis ball, a metal puck, or a paper cup. The grip force is adjusted to match the shape and weight of each item. This hand can even play the piano.